Hello everyone, I am Shayok from JIS University, Kolkata, second year CSE student. Here team Mythical Phoenix would like to explain you great innovative project that is developing a solution for gesture-enabled commands for operating laptops, PCs for frequently used operation on daily basis. So next, come to our team members part. So our group members are Ritik Pal, Nath, Debashish Show, Abdul Naim, and Rusdar, and me, Shayani Ghoto. Mentor of our group is respected Sir Mr. Sanjay Chakraborty. Next. So here is the contents part. So now I'm starting with introduction part. So as I said that we are making a project that is based on air gesture using OpenCV. So we all know that gesture recognition is an active research field in human-computer interaction technology. So our goal is to design an application that will use only webcam. Here we will do lots of function depending upon our various gesture like hand, etc. So we will discuss about it more. So now now the next slide will be continued by Devashish. Devashish, please continue.
So good afternoon, everyone. I'm Devashish Sau, member of Team Mythical Phoenix. I would like to demonstrate about the overview of this main idea of our project, that is solution for gesture animal commands. So our given problem is given by DRDO, and we would like to thanks for giving us this awesome platform to solve the real-time problems. So people need an easy method to control their devices without touching their hands on the screen. But design an application for everyone to use their devices in an easy process. So we need a webcam or any kind of external camera to control the system, which takes hand gestures or blinking eye as an input and convert it as a command and execute the whole process. So we used Python for this machine learning part. So we all know in modern days in smartphone or in laptop, we have used many kind of gestures in our day-to-day life. Like write letter P for open the collar app in phone, or swipe 3 fingers to take a screenshot in touchscreen or in touchpad of the devices. So in this case, we develop this hand gesture and eye gesture system and execute it successfully to control various things. Firstly, we detect various hand gestures and recognize and interpret through computer vision with the challenging factors which variability in pose, orientation, location, and scale. Through the webcam system, we take the image from the real-time video and analyze the gestures via hard cascade classifier of hand before the image processing is done. Or in other words, to detect the appearance of a hand in a frame. Now in next slide, signing. Yes. So now in component parts, we used Python for the base programming to create this application. So Python is a general purpose interpreted, interactive, object-oriented, and high-level programming language. And we used Visual Studio Code, which is a free, powerful, lightweight code editor. And we used OpenCV, NumPy, TensorFlow, MediaPipe, Pkinter, and PyQt5 libraries or packages of Python. So now OpenCV is a computer vision package which help to open the webcam part and help to take the real-time video from the user. And NumPy, TensorFlow, MediaPipe, all these packages helps to process the internal part of this program, and Pkinter and PyQt5 libraries is for creating the user-friendly GUI. So now I would like to hand over the next part to demonstrate the setup and algorithm of the application is work. Ritik.
Okay, thank you so much, Devashish, and good afternoon to everyone. So first of all, I want to take a look on the experimental setup. So first of all, we need to know that how the application works. So basically, the backend of every application has defined out of experimental setup. So in case our application like in the air gesture or the facial recognition of the application, we also have some different experimental setup. Like we use some packages, we use some file, and we also rename the file. So it is easy to use if you rename something like file. Like we use a visualize.py, the label.py, sign.py, dataset hand.py. So let's explain what the files are doing. Here the visualize.py has a great impact, because whenever we use our application to run in the IDE text editor, we use a visualize.py because it will. The label.py, it is used for the training, because we here use the CNN algorithm by the convolutional network algorithm we use. So we have to train our module, we have to create our module and train it, and we have to do different types of things, like we have to use train test set date, and we have to also something like we have to collect data from different users. So everything will be connected in there, and then there will be a great application is built, and whenever we want to get output, visualize.py will help us. Next, we can give the sign.py. So here the sign.py will obviously shows the layout. So every application has an interface and another has a layout. So without a layout and without the interface, no application will be best. And in the next is a dataset hand.py. So what impact dataset hand.py? I first of all I will tell that label.py is a great impact of, and visualize.py shows the output. Dataset hand.py will be collected the data from users. It will collect the data from the users, and it will train the data through label.py and shows the output in visualize.py, and it will be connected to layout with the sign.py. So next slide, please. Okay, so first of all, let me explain the algorithm. I'm not going to explain the CNN algorithm because we all of us know the CNN is a artificial intelligence convolutional network link algorithm. But I'm going to explain the algorithm of our application. So what impact, what does it? So first of all, our application starts from the importing all the packages for a particular file. Okay, let's layout file. So in case of layout.py, the sign I told you in the past slide. In the sign.py, we have some packages we were going to import. Then we set our root, then set our images. We then geometrically set our layout. We set the 350 and 400 width and height. Then we are going to create the label. We create define as a button. And also we are going to do some required function, like we have to show our next slide, next layout. Next that's, and the train level, we also know that we are going to train our data. We also import all packages at there, because in the train level there will be some values, there will be some training data, and we also set the array there. We are going to set a 2D array, because we all of the training model also set the test module, so that whenever our data is complete, we can also test it. So here step 28, until 28 is all stuff has been done. Okay, so the next step 29, or next slide please. So next step 29, here we are calling our convolutional networking. Okay, here we use our convolutional networking, like we are going to max pooling, we are going to your DNN, and we also connected all the things, because without the connecting neural networking, it will be nothing. So after all of this, and then after all of this, we are going to save our file as an extension of .tflearn. Okay, so .tflearn causes all of the 2D matrix value in the binary or in the some kind of values. Next, in the visualize.py, we are going to import all the packets, and then we are going to calling our tflearn value, whichever we saved in through the label.py. So we are also using media pipe, whatever Devashish told us, the media pipe package is also used. So here we are calling the media pipe packages to show us a hand recognition. Also we are using face recognition in the same case, because without media.py we cannot call the hard cascade. Even we cannot detect the landmark of our face or hand. So here until all of steps has been done. In the next slide, step 43, or the next slide, step 43, we are going to see the Boolean value. We are to set the frame value. Also, we are going to set X and Y axis so that it can detect only our face, or it can detect only our hand. So it is done because we don't want to detect other things like the wall, the other objects. We just detect only specific things, and only specific things movement or sign. So here all of things has done. And in the step 52, there is a main part. Whenever we load our model, to load our TF-learn model, we are going to predict what kind of value it will be. If the value from the picture, live webcam picture, will be same as the model TF-learn, whatever we saved as is same, so it will does something stuff. Like you can see that whenever our value is 0, so it will be do something. Value is 1, it will do. Value is 2. Next slide, please. You can see the same thing when a value is 3, 4, 5, and etc. There's more value and more stuff you can do. And in the future, there will be more operations will be there. Right now, we are implementing 9 operations for the hand, and we also implement our face recognition, which will upcoming slide or upcoming videos. So here also we did same stuff. In the step number 66, what is the main? This is a frame frequency, and this is going to be stop our frame. What does it mean? It means our frame will be continued for the 5 milliseconds, and in the 5 milliseconds, whenever user press A, like you can see the 65 ASCII value, whenever user spray this through keyboard, our loop will be break. So here this all stuff is done. And in 67 step, we also release our webcam, and 68, 69 is the same case. So next slide, please. Next slide. Yeah. So 7 and 72, you can see the eye detection, the same case, or the blinking detection, or the anything detection. We are performing the same operations. And in the face layout, we connect our face detection module. For the emotion detection module, connect the emotion detection file. For the hand detection, we are going to air gesture file. And all of the stuff has been done, and it will be goes until the user stops the application. Okay, because if users want to go to air gesture, it will click on the hand. If users want to motion detection, it will go to the face. But whenever users stop the application, just go and click the cross button, so the application will be stopped. And in the 73 step 73, this whole thing will be written in the buttons. So that's it. Here is my algorithm. So I would like to request Ruzda to explain the next slide. So thank you.
Good afternoon. Now we'll see its application. It may be possible for some devices to change their shape to better mimic their real-world counterpart. For instance, a mute person may be used such a device, a place of Google Assistant, since he is unable to talk. Using gestures will suffice his requirements. This may be part of training environments where the participants interact with the same devices they will use in the real world. Now I'd like to request Abdul Naim to continue the slides.
Thank you, Usta. Our application has some dependencies that the user has to keep a standard quality webcam or use a standard laptop with good webcam. Stable internet is required for our application to download it. The application, which is the application is installed, should be in good condition, that is without any bugs or software issue. Next slide, please. Here is some screenshot of our project, that how it works. So I would like to invite Sorasis to continue.
Thank you so much, Abdul. Okay, so now I will continue with the future scope of our project. So while the gesture recognition may reduce the need for handheld devices, yet another avenue could lead to a vast infusion of specialized input devices. You can see that our device means our application is really futuristic because it has never been done in the past. In the future, there may be custom devices for virtually every different type of activity in a virtual environment. We have designed this kind of application so that it may help everyone, and also it may help the people with disabilities, such as the mute people who cannot talk. They can use these air gestures and their facial gestures so that the program may recognize these gestures and they can be able to perform their tasks. So on the desktop, the interface has remained focused on the keyboard and mouse, but these things are now getting a new types of designing. And so in the future, the input devices will be a lot less compatible, rather than people would like to use these kind of virtual environments to do their tasks. There have been developments in handwriting recognition, voice recognition, gesture recognition, haptics, eye tracking, and wearable computers. But this kind of sophisticated environment, where every such air gesture movements are detected and at a single place you can perform so many functions, this has never been created before. So our next module based on eye tracking will be functional soon, and it will function just at the blink of the user's eyes. You can perform any tasks whichever is specified within your blink of an eye. So it is a really fast module, and we are working on it currently. It will be operational very soon. And we are aiming to develop this application in such a way that it receives mainstream recognition and performs all the functions which are required. So now I will move on to our marketing part. A major change is occurring due to the increase in functionality of automotive software applications, along with a significant reduction in pricing. So the use of accelerometers to measure motion when applied as input signals to computers has been well documented for many years. And as we can see from this kind of graphs, that these applications are really very powerful, and also the market looks forward to receiving new kinds of things. So this air gesture recognition has never been used as an application before, not any web apps or anything. So currently there are no such applications which are available on the market, and this can provide a new kind of approach to the different companies, and it is a sophisticated solution to bring a lot of functions using gestures at a single place. That's why this is really innovative, since people would like to get all of their requirements drawn onto them at a single place. This is why launching this application will help solve a lot of problems of our world. Thank you so much. And now you can see this is our team Mythical Phoenix. We are really happy to bring this to you, and our team member Shani Ghatak will explain next the full working of our model which we have designed. Thank you so much.
Yeah, thank you.
Hello everyone, I am Sharmi Ghatak from team Mythical Phoenix. So now the time is to show you some work of our project. Okay, as we said you in our PPT that we are making a project on air gesture using OpenCV Python, and we are using lots of function here depending upon various gesture like hand, face, eye, etc. So now let's see of our project. Okay, so here you can see that this is our layout of our project. Now here is written that please enter your name. So now simply I am entering my name here, Shayoni Ghatak, and just hit the welcome button. Yeah, you can see that here is written that welcome Shayoni Ghatak. User can also write their name in this part and also press this button, and they will also see this. Okay, now I am pressing the enter button. Yeah, so you can see that here we use lots of button here. So now come to one by one. Okay, so firstly starting with this team member button. If I press here, you can see that here is our team members and our mentors details is present here. Yeah, our team name is present here and etc is present here. Every details is present here. So this is for team members details. So now I am pressing the back button. Okay, pressing the back button. Now I am going to show you this hand instruction part. Oh, one more thing, that you can see here that here we use total 3 mode. One is for hand detection, another is for emotional detection like happy, sad or angry, and another is for eye detection. Okay, and this icon is showing you the instruction of this gesture. Okay, now I'm pressing this hand instruction of this hand button. Okay, you can see that there is lots of instruction is present here like open, save, shut down, print, unlock, restart, close, turn off, screenshot, unlock, turn on, etc. And we will add lots of extra thing here. Our work is going on now. So now the next coming to the emotion icon instruction. Here is an emotion instruction that is happy, sad and angry. We just use it. Okay, so this is all about the buttons. Here you can also see this cross button. It will help you to quit from this layout, okay, from this program. So next, now I am showing you this hand detection or main part. Okay, I am just pressing it. Yeah, it's running. It will open very soon. Yeah, it's open. Okay, so now I am showing you how it's work. Okay, so let's start. I am showing you how our hand detection it's working. Okay, so now let's start. I am showing you this finger for opening Wattpad. You can see that when I am showing this finger, the Wattpad is open. I am closing it, Wattpad is closed. Again open it, it's open. Again close it, it's open. And one more thing, I am not using any kind of other device. Okay, just you can see my another hand is here. Okay, just open. Yeah, I want to close this Wattpad using air gesture. It's closed. Okay, it's based on the hand detection only. And now I want to save the Wattpad. Okay. Okay. Again, I am opening this Wattpad, closing it, open. I want to write something here and want to save it. Yeah, you can see that is saved here. Okay. That way the save folder is opening here, and I want to close it. I can yes, that is good. You can see that my another hand is into here. Okay, I am not using any kinds of input device. I am saying is again and again. Okay, now I am showing you the next another interesting part, that is screenshot. Yeah, you can see it's take the screenshot and it's the store in our folder. You can see beside the pink box that is shot is written. That means it's take screenshot of my page of this page. Okay, so let's see where is this screenshot. So next come to our folder. You can see that lots of screenshot is taken here, present here. So let's open one. Yeah, you can see this is the screenshot part. Okay, lots of screenshot is present here. So this is a different feature in our project. This is a totally new features, and here we use lots of things like lock, unlock. Now I want to show you how it's lock my computer and how it will open. Okay, so let's show you. Yeah, you can, I don't know, you can see this or not. See, my computer is locked here, and if I use this sign and my computer is unlocked. Okay, now this is here. Okay, so now this is lock and unlock part, and here is also one more thing, that is the print part. So now I am showing you that our PDF, it will show you the printing dialog box. Now the Google Chrome is open here. If I show you the one specific finger, it will show you that the printing dialog. It will work on Wattpad and everything. So now let's start. Okay, I am showing it now. So you can see that our printing dialog is open here, and it's worked very nicely. And it will work in Word and also in the PowerPoint, in everything. Okay, so this is the main feature of the PDF or printing dialog. So this is the printing dialog. So now the next I will show you. So now I am showing you the shutdown process using hand gesture. just using hand and gesture. Okay, so let's start. Shutdown. You can see that. You can see that my PC is shut down now. So now I am doing here the so now I am showing you the restart function using just a hand gesture. Okay, so now let's see what is happening here. I'm showing it. You can see that it will be restarting. Okay. So now I am showing you the next thing, that is the alt and shortcut key alt and F4 function. Okay. So as you know that alt and F4 function is how it's work. It's work like that. If some program is running, then it will be turn off thing. So now I am showing you the turn off button that will show you shutdown and restart button in a window. Okay, let's see. The dialog box is blinking because all the applications are called when I showed the sign of my hand. You can see that the window is presenting here. You can see there's the shutdown option is here and Windows 10 is written here. My processor is Windows 10. So this is the function of Alt F4. I just did it using the only hand gesture. Okay. Okay, so you saw that our hand detection here, hand detection, and here is the instruction of hand detection. Every instruction is present here, and you can see that in hand detection we are not using any kind of other device like mouse, keyboard, nothing. We are using nothing. We just use our hand for opening Word and closing the Word file and saving something in Word, and also we are just and also we can lock and unlock our computer using just hand gesture. Okay, so this was the hand gesture. Now I want to show our next work, that is in emotion detection. If I hit this button, you can see that all emotions instruction is present here: happy, angry, and sad. So now let's see what is happening in these emotions. Okay, I am pressing this button. So same one window will be opened here. Yeah, it's opening. Okay, now you can see that in our beside of the blue box that angry, happy is written here. That means that is detect of your face emotion. Okay, now I am doing something like that. You can see that my face is angry, and it's also written here that is angry face. Okay, now I will show you the happy face. You can see that my face is happy now. It's showing happy here. Okay, so this is all about the emotion detection and hand detection. So I think this project is good for everyone. Don't need any kind of other device like mouse, keyboard, anything. You can do any kind of work using this air gesture. And one more thing, we are just increasing our work now. We are working in eyes also, and we will add lots of features here in future. In future we will add lots of things, and so this is all about our project by Mythical Phoenix. So thank you so much. Thank you to SIH hackathon team for that. Thank you for that. You all are just giving us for showing our talent here. So thank you so much. Thank you very much. Thank you.